All right, so let's continue to talk about the tsunami that occurred in the Indian Ocean in 2004. So as you can see, the earthquake originated right here. Okay, so we've got a pretty complicated boundary going on right here. So we've got a, you can see a divergent boundary offset by our transform faults right here. And you can see that, right, you've got a transform fault that kind of goes across Sumatra a little bit. And we've got our divergent boundary. However, right here, right, we've got some pretty complicated stuff going on. We've got a transform boundary occurring right over here as well, and all along this whole plate. So this is a pretty complicated situation. So essentially what we got was that major snapback effect. And because of that snapback effect, you can see that that wave raced across the Indian Ocean, right, in all directions. And it was really bad right here because, as you can see, it's just getting funneled up into this tiny little bay, and it's getting funneled up into this bay as well. So it didn't really give that wave any chance to dissipate at all, right? It had all this energy and it just raced up right on top of the land. So as you can see, to me this is pretty impressive, our before and after picture. So before, you can see a very lush and healthy area. It's very green, lots of buildings there. However, after the tsunami, look at how far inland, right, this area was devastated. So that wave came in and it quite literally ripped the grass off of the ground. It took everything out with it. So this whole area is now completely barren. And then, of course, right, if we go to Japan here, there was a huge earthquake, right, not that long ago. It was another 9.0 where we got that snapback effect. And that tsunami came ashore in 10 minutes. So that doesn't really give you a lot of time to prepare, right, for anything like that. And as you can see here from this picture, it just quite literally erased almost everything on the ground, just wiped it clean. And the major problem here was that there's a nuclear power plant that was inundated with seawater. And the problem is here, right, is this area, obviously these nuclear cooling ponds cannot take on seawater because that seawater is going to corrode structures, corrode the concrete, corrode all of the electrical there. And this whole area was under 46 feet of water. Now that's pretty impressive. And you can see here, right, all the hydrogen explosions destroyed the reactor buildings. So now you've got nuclear materials, right, leaching out into the ground, into the air, into the ocean. So this can pose a huge, huge problem. So obviously we need to be really careful here about tsunamis, and we need to be able to learn how to much better accurately predict them. Fortunately, we have these buoys that sit out in the ocean, and they can predict these little waves, because remember, these waves aren't going to be big out in the deep ocean, but they can predict, they can kind of track these waves as they're going across the ocean. So getting a better handle on when a tsunami occurs and where it's going to go is getting a little bit better for us. We're getting a little bit more of that knowledge. And, you know, prediction of these tsunamis can really save thousands and thousands of people, right? People given enough warning to be able to get themselves and their loved ones up on higher ground, right, away from these devastating waves.